Hi everyone. Today I'm going to share a unique story of sustainability in the construction industry. Imagine turning something as ordinary as eggshell into an innovative material for self-compacting concrete beams. It improves productivity and reduces waste on construction site. This study seeks to understand the behavior of SCC beams. Our dynamic team has set out to achieve three ambitious goals. The first one, to evaluate the structural integrity of SCC beam. For the second one, to closely examine the crack pattern and behavior of this beam under flexural stress. And the last one, to validate our finding against the Eurocode standards. Our study tackles several issues in the construction world: the highest cost of SCC, the environmental impact of swing correction, and the lack of international standard are just the tip of the iceberg. Moreover, the extensive trial and error is not only costly but also time-consuming.
Some research have been conducted about self-compacting concrete known as SCC. SCC covers formwork completely, enhancing compaction and reducing the need for skilled labor. It can also incorporate waste materials like fly ash, silica fumes, plastic waste, and tire rubber, maintaining performance while reducing environmental impact. Additionally, SCC uses fewer and smaller coarse aggregates, which affect its mechanical properties. Eggshells as partial substitutes for sand or cement has shown positive results in maintaining or enhancing concrete strength. Flexural strength in beams have been found upsurge with increasing compressive strength of concrete, while extensive research has been conducted on reinforced concrete beams with various additives or waste materials. There is limited information on the failure behavior and crack patterns of SCC beams that include eggshells as component in flexural tests, leaving this area open for further investigation. In summary, SCC offers significant advantages in terms of compaction, sustainability, and strength, making it a revolutionary material in the construction industry.
So the procedure for this in this experiment can be categorized into two. First is to prepare the materials for SCC mixture and its proportion, and second is to evaluate structural strengths and assess crack patterns. So the materials that we use is the ordinary Portland cement, coarse aggregate with a size of 10 mm and can be obtained from a quarry. For fine aggregates, we use natural sand, and for eggshell powder can be obtained from any source, and they should be grinded and crushed until they turn into complete powder. For super plasticizer, we use BASF Mercer-Glanium 8784, which can be obtained from BASF Sdn Bhd in Selangor. So this is the quantity of substitute materials in the units of density. So in order to gain the weight of each of these material, we must multiply them with the volume of a sample that we want to test on.
After 28 days of casting,
So in this
is a
study,
very
a total of 6
important
SCC
measurement to
cubes
assess the
with
quality
a
of concrete.
dimensional size of 150
The
times
concrete
150
cubes are
have
cast,
been casted and
cured for
tested for
28
assessing
days and
compressive
tested
strength
on a compression
after
testing
7
machine.
and 28 days.
Before testing,
Every SCC beam specimen has been tested for failure under bending test, which is the 4-point flexural test, at various ratio of A/D, which means the shear span to effective depth. The load applied was increased continuously until failure at a displacement of 0.01 mm per second. So this is the crack formation from this study, which has been delineated on the every SCC beam specimen.
Continue on the result and discussion. For the flexural strength testing, SCC beams with Eggshell hold up well, especially at lower A/D ratios, whereby the load plays close to support. The beam won't look affected deflection. For the type of crack, shear crack found mostly at supports, flexural cracks in the middle, and shear flexural at quarter points. The cracks spread more with higher A/D ratios. All crack widths were safe according to Eurocode 2. The experimental crack width fulfilled the maximal theoretical crack width, which is between 0.3 to 0.4 mm. As for the critical crack wave angles, it ranges between 28 degree and 55 degree. It is closely matching your two predictions and were mostly detected in shear areas. So this finding highlight the effects of A over D ratio on load bearing and deflection in SCC beams and the consistency of a crack behavior with the international standards. In conclusion, SCC beams sustain higher loads and have a better deflection control at lower A over D ratios, thought they can be brittle. Using a GoWist in SCC reduces environmental impact while ensuring strength and ductility for the structure.